Welcome to this educational video on reclaim wafers. In semiconductor manufacturing, wafers are used not just once. They can be reclaimed, reprocessed, and reused. A reclaim wafer is a used semiconductor wafer that has been stripped of its thin film layers, repolished, and restored to a condition suitable for reuse. This process supports four key values: resource recycling, cost reduction, environmental protection, and a sustainable future. In this video, we'll cover the definition, types, manufacturing process, applications, and market outlook of reclaim wafers. So what exactly is a reclaim wafer? In a semiconductor fab, wafers go through hundreds of process steps: deposition, etching, lithography, and more. After these processes, the wafer surface is covered with multiple thin film layers. These used wafers can be reclaimed. The thin films are stripped away, the surface is repolished using CMP, chemical mechanical planarization, and the wafer is cleaned and restored. The result is a reclaim wafer, ready to be reused in the fab. The benefits are significant: up to 80% cost reduction compared to prime wafers, reduced industrial waste, and a price point of just 1/5 of a new prime wafer. Reclaim wafers come in 5 distinct types, each designed for specific applications. Type 1, bare reclaim. The surface is stripped and repolished to a mirror finish, used for general process development and testing. Type 2, oxide reclaim. A thin thermal oxide layer is grown on the reclaimed surface, ideal for oxide process modules and CVD testing. Type 3, patterned reclaim. The original device patterns are preserved during reclaim, used for advanced process development closer to actual production conditions. Type 4, monitor and dummy wafers. These have standard structures for equipment monitoring and process uniformity checks. Type 5, epitaxial reclaim. An epitaxial layer is regrown on the reclaimed substrate, used for high-performance device testing and epitaxial process development. Let's walk through the reclaim wafer manufacturing process. 6 key steps. Step 1, wafer collection. Used wafers are collected from the customer fab after processing. Step 2, visual inspection. Each wafer is inspected for cracks, contamination, and surface damage. Step 3, film strip etching. The thin film layers are chemically stripped from the wafer surface. Step 4, CMP repolishing. The wafer surface is repolished using chemical mechanical planarization to restore flatness and smoothness. Step 5, cleaning and drying. The wafer undergoes rigorous cleaning and drying to remove all residues. Step 6, final QC and shipment. The wafer passes final quality control checks before being shipped back to the customer. Key metrics. Each cycle reduces wafer thickness by 5 to 20 micrometers, and a wafer can typically be reclaimed 3 to 5 times. How are reclaim wafers actually used inside a semiconductor fab? There are 6 primary applications. First, equipment PM verification. After preventive maintenance, reclaim wafers are used to verify that tools are performing correctly before running production wafers. Second, new recipe development. Engineers use reclaim wafers to develop and optimize new process recipes at a fraction of the cost. Third, deposition and etch conditioning. Reclaim wafers help condition chambers and stabilize processes before production runs. Fourth, process engineering evaluation. They are used to evaluate process windows and performance metrics. Fifth, equipment training. New operators and engineers can train on real tools using reclaim wafers without risking production wafers. Sixth, sustainable manufacturing. Using reclaim wafers reduces waste and supports ESG goals across the semiconductor supply chain. The reclaim wafer market is growing rapidly. The global market size was approximately $1.2 billion in 2023 and is projected to reach $5.1 billion by 2030, a compound annual growth rate of 15.3%. What's driving this growth? 4 key factors: the surge in AI demand, the rapid expansion of electric vehicles, tightening ESG regulations worldwide, and the semiconductor industry's relentless focus on cost optimization. As fabs scale up production and face increasing cost pressures, reclaimed wafers have become an essential part of the supply chain, not just a cost-saving measure, but a strategic sustainability solution. Let's bring it all together with a comprehensive comparison of the 5 reclaim wafer types. Bare reclaim offers the lowest price and process difficulty, ideal for general testing. Oxide reclaim adds a thermal oxide layer, making it suitable for oxide-related process modules at a low to medium price. Patterned reclaim preserves real device patterns, offering medium to high process difficulty and yield assurance, closest to actual production conditions. Monitor and dummy wafers provide high yield assurance with standard structures for equipment monitoring. Epitaxial reclaim is the most advanced. With an epitaxial layer regrown on the substrate, it supports high-performance device testing at the highest price and process complexity. Each type serves a distinct role in the fab ecosystem, and choosing the right type is key to maximizing both quality and cost efficiency. Reclaim wafers are more than just a cost-saving tool. They represent a smarter, more sustainable approach to semiconductor manufacturing, one that balances economic efficiency with environmental responsibility. As the industry continues to grow, reclaim wafers will play an increasingly important role in keeping fabs competitive, agile, and sustainable. Thank you for watching. This has been Wafer Agent.